All right, this is going to be my second video working through trig proofs and the more common identities we encounter. And I have on the right hand side of the screen a copy from a textbook of their trig identities and the ones that I'm more than likely going to be using. And so we're looking here at this very first one. And the more of these problems you do, the better you get, because not only are you learning the identities, but you're also learning how to approach the problems as you go forward. And if I'm looking here at this, this first proof, I have two separate terms that I need to combine into one term. And so my approach is going to be to rewrite tangent as sine squared over cosine squared. And I'll leave sine squared of x alone. Now, if I'm going to combine these, I do need to rewrite sine squared as a fraction, which is going to make sine squared over 1. And then to combine these two together, I have to have common denominator. So I'm going to multiply the sine squared by cosine squared x over cosine squared x. And now I'll have common denominator, so I can put these together, and I'll have sine squared x minus, it'll be sine squared times cosine squared all over cosine squared x. All right, so now it's combined into one fraction. And from here, I look at my numerator, and I have a common factor of sine squared. So I'm going to pull the sine squared out. I'm going to factor it out. So that's going to make sine squared x times 1 minus cosine squared x over cosine squared x. Now, if I go refer to my trig identities, 1 minus cosine squared is a Pythagorean identity, and I'll highlight that right here on the right-hand side, is that makes, let me make that highlighter a little smaller. All right, so sine squared plus cosine squared is 1. And I'm going to use that identity to replace 1 minus cosine squared. And so my problem becomes sine squared x times 1 minus cosine squared is sine squared. And I have over cosine squared x. Now, the multiplication part here is I'm going to put that cosine squared up underneath the sine squared. And lastly, sine squared over cosine squared is tangent squared. And times sine squared x. And that is my right-hand side, so proof completed. All right, let's go over here to our next one. Cosecant to the fourth minus cotangent to the fourth, and I want to rewrite that as cosecant squared plus cotangent squared. We can factor this right-hand side as it makes a difference of squares. It makes cosecant squared x minus cotangent squared x times cosecant squared x plus cotangent squared x. So a difference of squares, I'm going to factor that, because that will bring me down to having exponents of 2 everywhere. And now I'm looking how to proceed. Well, I have cosecant squared plus cotangent squared. And so I have what I want right here. So I'm only going to manipulate the other factor and see if I can't make all that go away and become a 1. And so to do so, we're going to refer back here to our Pythagorean identity. So we have cosecant squared and cotangent squared. And what I'm going to look at is 1 plus cotangent squared is equal to cosecant squared. So I'm going to replace the cosecant squared with 1 plus cotangent squared. Well, that's going to make the cotangent squareds are going to cancel. That leaves me with just 1 times cosecant squared plus cotangent squared. And so I have reached my right-hand side. Cosecant squared x plus cotangent squared x. And that is my right-hand side. Okay, next one here. All right, 1 plus tangent x divided by 1 minus tangent x. And I look at my right-hand side, everything has sines and cosines in it. And so an approach here to start this problem, because we can't really use a Pythagorean identity because there's no squared terms in this left-hand side, is I'm going to rewrite everything in terms of sine and cosine and proceed from there. So tangent of x is sine over cosine x. All right, we see that right here. So 1 plus sine x over cosine x divided by 1 minus sine x over cosine x. So I use my quotient identity. Now, from here, what we're going to do is we don't want to have that complex fraction. So I'm going to multiply to get rid of the denominator of cosine everywhere. So I'm going to multiply both the numerator and the denominator by cosine of x. In doing so, and I distribute that cosine x, that makes my numerator become cosine of x plus sine x divided by cosine of x minus sine of x, which subsequently is my right-hand side. So proof completed. All right, next one here. Cosine of 3x. And I want to make that become cosine cubed minus 3 sine squared cosine x. Well, I'm going to have to use some multiple angle identities here. And in fact, I have to break up out of the very beginning, because we don't have a triple angle identity, I'm going to break up cosine of 3x to being cosine of 2x plus x. And we zoom out here, and so we're going to be focusing on cosine of angle sum right here. So when I do that, cosine of 2x plus x is going to become cosine of 2x times cosine of x minus sine of 2x sine of x. And I want to keep breaking it down because all of the insides of the trig functions are just 1x. So I'm going to continue to break this apart. Now, there's only one option to use for sine of a double angle. So I'm going to go over to my double angle identities. And for sine, we have sine of a double angle is equal to 2 times sine of the angle times cosine of the angle. Now, when it comes to cosine, we have 3 options here. And we need to pick which option to choose from. Well, we need to make cosine cubed. And looking at my identities, to make that cosine cubed in my problem, I'm going to have to pick one that's got cosine squared. So that would bring me to either cosine squared minus sine squared and 2 times cosine squared minus 1. Well, which one I would pick, I don't want to have more than one of the cosine cubes looking at my right-hand side, so I'm going to go with the top one. And so we're going to rewrite, we're going to use our identities. Cosine of 2x makes cosine squared x minus sine squared x times cosine x minus, and then we're going to do the double angle formula for sine, which is 2 sine x cosine x, and I still have times by sine. And then we're going to multiply this thing out. And so we'd have cosine to the third x minus sine squared x cosine x minus 2 sine squared x cosine x. And we combine our like terms, and we're going to make our right-hand side here. Cosine cubed x minus 3 sine squared x cosine x. And I have my right-hand side. All right, next one here. Tangent of x plus y times tangent of x minus y is going to make that right-hand side. Well, let's refer to our angle sum and difference identities that we have for tangent. And so we're going to use these identities here, and you see the identities here on the right-hand side. So there's my angle sum for tangent. Here's my angle difference for tangent. I'm going to put those in. So tangent of x plus y is going to become tangent of x plus tangent of y divided by 1 minus tan x tangent y. And we're going to multiply that to tangent of a difference, which would be tangent x minus tangent y over 1 plus tan x tan y. And let's multiply those two fractions together. We have a difference of squares here. So when I multiply the two numerators together, that's going to make tangent squared x minus tangent squared y over, and I have a difference of squares in my denominator as well. So it's be 1 minus tangent squared x tangent squared y. And that's my right-hand side. So proof done. All right, next one here. So this one we have cosine of 6x. And I want to make it become 2 cosine squared of 3x minus 1. Now looking at the problem and how to proceed, I have cosine of 6x and I wanted to have cosine of 3x. So I'm going to rewrite this so that way I can use a double angle identity for cosine. Cosine of 6x is the same thing as cosine of 2 times 3x. And so let's refer to our double angle formula, or formulas per se, for cosine. And I want to pick which one to use. Well, the one that matches our right-hand side the most is cosine of 2 times x is equal to 2 cosine squared x minus 1. Now, when I go and I do that, I have to be wary of the angle I'm doubling is 3x. So cosine of 2 times an angle is the same thing as 2 times cosine squared of that angle, which our angle is 3x, minus 1. And that is our right-hand side. So that was just a direct application of the cosine of the double angle formula right there. All right, let's change gears. Now let's look at sine of 3 times x. All right, well, I need to look at where I want to go. So everywhere on my right-hand side, I just have 1x there on the inside. So I need to break up this sine of 3x until eventually I get it all the way down where it's just 1x on the inside. So I'll rewrite sine of 3 times x as sine of 2x plus x. And then we're going to use our angle sum identities, or our multiple angle identities, however we want to say it. And so let me pull up my sum and difference. So that way you can see where I'm getting this from. And sine of 2x plus x. So two angles adding together. This is the formula I'm going to use right here on the right-hand side. So that's going to make sine of 2x times cosine of x plus cosine of 2x times sine of x. All right, so I've reduced the inside of the angle down from 3x's to 2x's. Well, now I have to do something with my double angles. So let's go back to our double angle formulas, and we'll figure out which ones to use from there. Well, we only have one option for sine of the double angle. Sine of a double angle is 2 times sine x cosine x. So I have 2 times sine x cosine x, and I still have times that cosine x there, plus, all right, now I have to do something with the cosine of 2x, and we got to play that game of, well, which one do I want to use? Well, when I'm looking at my right-hand side, I do not want to have cosine cubed anywhere, which I wouldn't necessarily have because I'm going to multiply by sine of x when I'm done. And so I have to pick strategically here. Well, if I'm looking at what I have on what I already have, meaning, let's look at this, 2 sine x cosine x cosine x. I really have 2 sine x cosine squared, and I need to wind up making 4 of them. So I could make 4 of them if I chose the cosine of a double angle formula that was 2 cosine squared x minus 1. And so I'm going to go with that one and say, all right, 2 cosine squared x minus 1 times sine of x. And then multiply this thing all the way out. And so we'd have 2 sine x cosine squared x plus 2 sine x cosine squared x minus sine x. And say, okay, well, that gives me 4 sine x cosine squared x minus sine x. And I go look, and my right-hand side, it pulls out a common factor of sine of x. I'm going to pull out the common factor of sine of x. And when I do that, that'll leave me with 4 cosine squared x minus 1. And that is my right-hand side. All right, so proof completed there. All right, let's go on to the next one. Now I have sine of 4 times x. And I want to break it all the way down, looking at this right-hand side, such that there's only a 1x on the inside everywhere. Well, the first move here would be to take the sine of 4x and rewrite that as sine of 2 times 2x. And use the double angle formula for sine. Which the double angle formula for sine, now remember, we're doubling the angle 2x. So it'd become 2 sine of 2x times cosine of 2x. And then now I have to continue to break this up. I want to break up the sine of the 2x and the cosine of the 2x at the same time. Well, we'd go to do that, and so we'd have 2 times sine of 2x would make 2 sine x cosine x. And then now I want to break up my double angle for cosine. And I look and say, all right, well, which one of those do I want to choose? I would choose 2 cosine squared x minus 1 because I see that verbatim on the right-hand side. And so I would use that identity for cosine. So 2 cosine squared x minus 1. And all we really have left to do is to multiply just a little bit here on the left-hand side. So 4 sine x cosine x times 2 cosine squared x minus 1 is my right-hand side. So we proved that the left-hand side can become the right-hand side. All right, let's go to a different one. Cosine to the 3rd power of x equals 1/2 times cosine x times 1 plus cosine of 2x. And I figure out, well, how do I want to proceed here? Well, we're going to wind up using some power-reducing identities. But my power-reducing identities only have, or they're reducing identities for trig functions being squared. So I'm going to rewrite the cosine to the 3rd power as cosine of x times cosine squared of x. And I look at what I just gave myself there. I needed to have a cosine x on the right-hand side, and I just gave myself that here on the left. And so now I'm going to work to manipulate the cosine squared. I got to do a power reducing identity. Well, my power reducing identity for cosine squared is 1 plus cosine of 2x divided by 2. And so we're going to use that. So we'd have cosine of x times 1 plus cosine of 2x divided by 2. And I'm looking at how to proceed. Well, all that's really left to do is to pull out this denominator of 2, and I would have my right-hand side. So I pull out a 1/2, and that makes 1/2 times cosine of x times 1 plus cosine of 2x, and we have our right-hand side. All right, move on to another one. So looking at this next problem here, we've seen similar situations where if you have two rational functions on the left-hand side and your right-hand side is one singular term, a good approach to start the problem is to put the two fractions together. So I'll go through the process of getting common denominators. All right, so we have 1 over 1 minus sine of x. It's going to have to get multiplied by the denominator on the right-hand side. So times 1 plus sine x over 1 plus sine x. And the fraction on the right-hand side is going to have to get multiplied by the denominator of the fraction on the left. So it's going to get multiplied by 1 minus sine x over 1 minus sine x. So that way I can put these things together. And when I do that, I'm going to have 1 plus sine of x minus, I'm going to write it as one fraction, minus, when I multiply that, I got to be very careful. A lot of people make mistakes here. They'll write minus 1 minus sine x. In fact, I am subtracting the entire numerator if I were to multiply it out, so I'd have to put in parentheses. And that'll be all over my denominator here. Which I'm going to go ahead and multiply the two denominators together. I usually don't do that because I hope something will cancel, but I'm looking at my right-hand side. I need to have tangent and secant, and so that means I got to have a denominator that's just of one trig function, not of multiple terms. So 1 plus sine x times 1 minus sine x makes 1 minus sine squared x. And then we put together our numerator. And so when I do that, let's see, the 1's are going to cancel. And then I'm going to be left with 2 sine x up here. And 1 minus sine squared. All right, that should look familiar. And in fact, it's a Pythagorean identity, because sine squared plus cosine squared is 1. So if I subtracted the sine squared to the other side, I would see that 1 minus sine squared makes cosine squared x. And we can create 2 secant x tangent x by rewriting our fraction showing a product of 2 tangent is sine of x divided by cosine x. And I still have another cosine that needs to go down there because it was cosine squared. So times another 1 over cosine x, which would create 2 times tangent x secant x. And that is my right-hand side. All right, so proof completed there. All right, and I got 2 more examples here in this video. So try and use as many different identities as we can. So now here in this one, I have sine cubed of 2x equals 1/2 times sine of 2x times 1 minus cosine to the 4th x. Well, I look at my right-hand side and I see I need to still have a sine of a 2x. And so I'm going to rewrite my left-hand side as sine of 2x times sine squared 2x. So I have something that I needed on that left side already. Well, now I need to do a power reducing identity because nothing on my right-hand side has a trig function that's being squared. So I'm going to go find the power reducing identity for sine squared. So sine squared of an angle is equal to 1 minus cosine of twice that angle divided by 2. So we're going to use that identity there. So this becomes sine of 2x times 1 minus cosine of 2 times the angle in there. So it'd be 2 times 2x, or 4x, divided by 2. And the last thing here is I'm looking in the right-hand side of my proof. Wants the 1/2 with the sine of 2x. So if I pull out a 1/2, oops, sorry, that makes 1/2 times sine of 2x times 1 minus cosine of 4 times x. And that is my right-hand side. All right, last proof here for this video. Sine of x plus y divided by sine of x minus y. Well, and I want that to become tangents. Tangent of x plus tangent of y over tangent of x minus tangent of y. So I have to break up the sum and the difference angles on the left-hand side. And so we're going to go find our sine of a sum and sine of a difference. And so sine of x plus y is going to become sine of x times cosine of y plus sine of y cosine of x. And then I would divide that by and use my angle difference. So sine of x cosine of y minus sine of y cosine of x. And now I'm looking and I'm asking myself, how can I make all of that become tangents? Well, that's a very good question. Let's look here. Let's go find a term. All right, so let's look at this top one. All right, how would I make tangent of x when I have sine of x times cosine of y? Well, I can make that if I was to multiply that by, because I needed to get rid of the cosine of y. So if I multiplied that by 1 over cosine of y, so that would remove the cosine of y. But the sine of x needs to be divided by cosine x to create tangent. So I'm also going to do a cosine of x down there. So if I multiplied that one term I highlighted by 1 over cosine y cosine x, I'd make tangent of x. So I'm going to do that. Now, when I do that, I'm going to have to do it to everything in my problem, so the entire numerator and the denominator. So in doing so, we would have sine of x cosine of y divided by cosine x cosine y plus sine of y cosine of x divided by cosine of y cosine of x. That's my numerator. My denominator would become sine of x cosine of y over cosine x cosine y minus sine of y cosine of x divided by cosine of y cosine of x. And we're going to see that some things are going to cancel for us. So the cosine of y's cancel, cosine of x cancels, cosine y's, cosine x's. And then we just simplify what we're left with. So sine of x over cosine of x makes tangent of x. Sine of y over cosine of y makes tangent of y. Divided by tangent of x minus tangent of y, which is going to equal our right-hand side.